Problems on Y-parameter continue. Here there is another question. Find Y-parameters of the network shown in the figure. This is almost similar to that of the earlier problem. The only difference is that here a current source has come. So similar to the earlier problem, first we will write the equation, first equation I1 in terms of V1 and V3, and I2 we have to write in terms of V2 and V3, and next we have to write the KCL at node 3. KCL at node 3. So we can write the KCL at node 3 as all the currents are shown as moving into the node. So we can take all the currents as negative, that is minus V1 minus V3 by 2 minus V2 minus V3 by 2 minus 3 V2 is equal to 0. So from this we have to find an equation for V3 and put that equation here. That is, we will get an equation for V3 in terms of V1 and V2 and put that equation in the equation of I1 in terms of V1 and V3. So we will get I1 and I2 as functions of V1 and V2, and from these two you will get two equations in terms of I1 V1 and V2 and I2 V1 and V2, and from this we can write the Y parameters. So I will give you the answers, do it yourself and send it to me. Y11 is 1 by 4, Y12 is minus 7 by 4, Y21 is minus 1 by 4, and Y22 is minus 5 by 4. Here we have another question. Determine the Y parameters for the network shown in the figure. Here we have capacitors and inductors. So when you get such a question, first of all you have to transform the circuit into the S domain. So here 1 by 2F will become 2 by S. If it was, if the capacitance was 2, then we would have wrote it as 1 by 2S. That is reciprocal of the value by S. Okay, the reciprocal of the value by S. Here 1 by 2, the reciprocal of 1 by 2 is 2 by S. Here also we have 2 by S. Here we have S. Here also yes. Here also we are going to follow the same procedure. That is, first we have to write the equation for I1 in terms of V1 and V3. Next we have to write the equation for I2. I2 here we can write as a sum. By taking the KCL at this node we can write I2. And then we will get I2 in terms of V2 and V3. Next we will write the KCL at node 3 to get V3 in terms of V1 and V2. Okay, so I1 in terms of V1 and V3 we will get, I2 we will get in terms of V2 and V3, and from the third equation at equation of V3, by taking the KCL at this node we will get V3 in terms of V1 and V2. So we will put this equation in these two equations and find the Y parameter equations. That is I1 in terms of V1 and V2 and I2 in terms of V1 and V2. Thus we will get the Y parameters. Let's see how we can do that. Beginning with I1, I1 is equal to, I1 is V1 minus V3 by 2 by S. V1 minus V3 by 2 by S. And we can write this as S by 2 V1 minus S by 2 V3. This is equation number 1. Now we can go for I2. We can get I2 by writing the KCL at node 2. KCL at node 2. We can write it as, we can take the currents in these three branches. Here V2 minus V3 by 2 by S, V2 minus V3 by 2 by S. Next we have this branch V2 by S plus V2 by S. In these two branches, the direction of current is not given, so we took it as moving out. And in this branch, we have the current I2 moving inwards, so we can take it as minus I2 is equal to 0. So we can write I2 is equal to V2 into S by 2 plus 1 by S minus S by 2 into V3. That is V2 into S square plus 2 by 2S minus S by 2 V3. This is equation number 2. Now that we have got the two equations of I1 and I2, let us go and find the KCL at node 3. At node 3, the current I1 is V1 minus V3 by 2 by S, and this current is moving into the node 3, so we can take it as minus. Now the current in this branch, that is, it is not given, so we can take it as plus V3 minus V2 by 2 by S. Next, the current in this branch, this also direction is not given, so we can take it as V3 by S is equal to 0. So now we can solve it. V3 into S by 2 plus S by 2 plus 1 by S is equal to S by 2 V1 plus S by 2 V2. So V3 into S square plus S square plus 2 by 2S is equal to S by 2 V1 plus S by 2 V2. That is equal to V3 into 2S square plus 2S square plus 2 will give you 2 by 2S will give you S square plus 1 by S. That's a 2 in the numerator and denominator will get cancelled off. Is equal to S by 2 V1 plus S by 2 V2. That is V3 is equal to S square by 2 into S square plus 1 V1 plus S square by 2 into S square plus 1 V2. So this is equation number 3, that is equation of V3. So now we have to put this V3 in these two equations, equation number 1 and equation number 2. 3 in 1. We have I1 is equal to S by 2 V1 minus S by 2 V3. See, this is I1. Sorry, equation number 1. So now we can put V3 in position here. That is S by 2 V1 minus S by 2 into S square by 2 into S square plus 1 V1 plus S square by 2 into S square plus 1 V2. This is equal to minus V1 into S by 2 minus S cube by 4 into S square plus 1 minus V2 into S cube, that is, this is S cube divided by 4 S square plus 1. So now we can solve this the coefficient of V1. This V1 into 2S into S square plus 1 divided by 4 into S square plus 1, taking LCM, minus S cube. that is equal to, let this term, I'm not writing it again and again, plus dash v1 into 2s cube plus 2s minus s cube divided by 4 into s square plus 1, and this is equal to v1 into s cube plus 2s by 4 into s square plus 1 minus v2 into, we have here s cube divided by 4 into s square plus 1. So we have got here equation number 4. Now we have to find the next equation, that is put 3 in equation number 2. This is equation 2, put v3 here. So now we can solve this. First we can write the v1 term. I have taken the v1 term first, s cube by 4 into s square plus 1, and we have got a minus sign here for v1, and next we have v2. We can write these two together, these two terms, this term and this term together. v2 into first term s square plus 2 by 2s. Here we have a minus s by 2. I have multiplied this s by 2 inside, s cube by 4 s square plus 1. v1 need not be solved again, so I am not writing v1, so I am writing v2 only. So here I have taken the LCM, 4 s into s square plus 1. So here we have to multiply 2 into s square plus 1, s square plus 2 into s square plus 1, and here we have to multiply with 1 s raised to 4 by, so 4 into s square plus 1. So now we have, here I have cross multiplied these two terms together, keeping 2 outside. Here I multiplied 2 with all these terms to get 2s raised to 4 plus 6 s square plus 4 minus s square. 2s raised to 4 minus s raised to 4 is s raised to 4 plus 6 s square plus 4. So now we have the equation. We can write the equation with v1 and v2 terms. That is equation number 5. That is I2 is equal to minus s cube v1 by 4 s square plus 1 plus s raised to 4 plus 6 s square plus 4 by 4s into s square plus 1. So this is equation number 5. So from equation 4 and 5 we can get the y parameters. So y11 is the term along with v1 in equation number 4. This is y11. This is y12. It is minus s cube by 4 s square plus 1. Then we have y21, same as that of y12, minus s cube by 4 s square plus 1. And y22 is s raised to 4 plus 6s square plus 4 by 4s plus s square plus 1. This along with v2. So this is the y parameter for the above circuit. Thank you.